longtime faculty member at Singularity University, the founder of Bespoke, and the holder of dozens of patents, and an expert not only on digital fabrication and design, but also on the ways in which exploring one set of technologies can allow us to transform existing industries and maybe to even imagine entirely new ones. So to join you all in breaking some rules and opening some new doors, please give a very warm welcome to Scott Summit.
So, how many people here have used a 3D printed product today? Great. How many have used a product that was created using 3D printing today? Okay, see, that's the trip up, because probably everyone here has. You just don't necessarily know it, because it's hidden behind the scenes most often. 3D printing is how the airplane... And so, I thought to myself, in my agony, wait a minute, this is a tremendous opportunity. I now have a chance to perform unlicensed medical experimentation on a live human subject. That's really hard to come by. It's expensive and dangerous, unless of course it's yourself. So I ran into the house, holding my arm, and I told my wife, something really fantastic happened. This is great. This is a game changer. I'll tell you about it on the way to the hospital. And you drive. And so we got to the hospital. And I told the doctor, well, first thing they did is they shot me up with painkillers. So I couldn't feel a thing. And I told the doctor, hey, I've got some ideas. Game-changing ideas. I'm going to hack the process, and I'm going to help you. And the doctor looked at me. He said, interesting. Are you a doctor? And did you go to medical school? I said, no. Much better. I'm a designer. I went to art school. And he thought that was really funny. He laughed for a long time. And when he got control of himself, he turned to the nurse and he said, this one's got enough painkiller. And so he's kind of that voice of the old world. He does the same thing over and over again. It's not very good, it's not very bad, hasn't really changed since the Romans, but it's safe and it's predictable. And he doesn't have to learn anything new or take any chances. Well, so that typifies a lot of products in our world. They're the same way they've been forever, simply because nobody thought to take a crazy chance and rethink it. Well, so the first thing I did after surgery is I clamped that cast in a vise, I pulled out a saw and I hacked it off very carefully. Pried that thing off and threw it away, and very carefully went to work the next day with my team. Now, I was the design director of 3D Systems, which was the company that invented 3D printing and was still kind of the Microsoft of the industry. And so I had the best team of designers and engineers, and I had the best equipment, and so we started to hack the process. Because I was going to go scuba diving in 3 weeks, and there was no way that this was going to get in my way. So the first thing we had to do was find out what was going on in there. So we took the CAT scan data, the CT data, and we sent it to Andy Christensen, who will be talking tomorrow. And his team cleaned up the data and sent it back to us, and we 3D printed my arm. So I could now hold my hand and look inside it. That's called data visualization. It's also called preoperative planning. But it's a way that you can actually look one-to-one at what's going on inside what's happening here. Well, then we had to make me digital. We had to put me in the computer. And so we put my arm in a 3D scanner that me and my team designed at 3D Systems. We scanned the outside of my arm. So now we could turn my atoms into bits. We added to those the bones from the CT scan, nerves, the blood flow, the muscles, and we drew onto that, we sculpted onto that with what's called a haptic device. And this is a device that lets you physically touch something that's on the screen. it recreates a physical sensation. So we're sculpting right onto my arm, in a sense. We tried many variations. We settled on this one. It's very simple, very different from what the Romans ever had. It covered the important parts and absolutely nothing else. So we called it the bikini. And a couple of things that came out about it that were interesting is that right after surgery, I was able to put hot pads and cold pads directly on the surgical site. That helped the blood flow and stop the swelling. I had acupuncture to stop the pain. It got sunlight. Most importantly, I took a shower every day. Normally doesn't happen when you have a cast. And I went scuba diving a couple times. So my doctor now borrows this cast when he does international events, and he talks about this amazing technology that he was really excited to be a part of. All good. So we looked at what this might look like in the future. What happens if you could 3D print directly on the body? And we kind of thought, well, this is science fiction, but had to do it anyway. It turns out there are groups working on exactly this. This is not too far off. And we did the numbers on this. It's a $2.2 billion industry. So it's all there. Now, what this speaks to is also a story of the democratization of design. When a couple people with the right tools can rethink a process left over from the Romans and come up with a $2 billion industry simply because you want to go scuba diving. You can't really do that unless you have the right tools. The tools open up the design. Well, as design director, often we got products coming from people looking for help with their 3D printing. This was one of them. It was a water filter that was 3D printed. It was a brilliant design. It was for people in parts of the world where clean water is hard to come by. And so we worked with the designer and we wanted to meet him. And so we asked him if he'd come up. We knew he was somewhere around Stanford, if he'd come up to San Francisco to visit us. And we didn't expect the response. She said, no, she couldn't come up to visit us because she couldn't take time off school and because her mother couldn't drive her up that week. And we found out, well, she's a 14-year-old girl in high school. And on top of that, she didn't want to do this as a business or to make money. She just thought it was a neat idea. She posted it open source to the internet, and now anybody who wants can download it and get clean, fresh, safe drinking water. And if they have a 3D printer, they can make one for their family or their village or sell them and become a factory. So this one product, the desktop 3D printer, this one was designed by me and my team at 3D Systems. This product turns a person into an inventor, an innovator, a problem solver, a manufacturer, a business. And these become the engines of the new world of innovation. Because these guys will grow up in a world always knowing that any crazy idea they have, they can hold in their hand and they can test and experiment with the next day. It's a very powerful idea for innovation. And in this case, the kids are 3D printing a prosthetic limb, which is also a very profound solution. But what they're getting out of it is they're learning about empathy, compassion, engineering, global empathy, global awareness. They are, because they have that one tool, a distributed, peer-to-peer, philanthropic manufacturer of an inventory. That the manufacturer wins because they don't have to have boxes and boxes of parts that they may never use. The consumer wins because if they buy that washing machine, they'll know that it's immortal. It will never die. They will know that they always have spare parts. But here's the weird one. The world wins as well. Because instead of that part being shipped around the world for the spare part, it's merely sent in this form to the nearest 3D printer to the consumer. And it's printed and sent locally. So would you rather have an inventory that looks like this or one that looks like this? It's a fairly easy choice. So companies are making this trend because it simply makes market sense and everybody wins. Okay, so back to that McLaren. Yeah, those really cool wheels don't help you if you go sliding in water and go slamming into a tree and you turn it into a paperweight. So wet road conditions, still a problem, always will be. And we're not going to 3D print tires. But it's not about 3D printing the tires sometimes, it's about the opportunities that come, in this case, from 3D printing the tool that makes the tire. Because when you're unlimited by complexity, you can make a new breed of tire that's essentially a rolling water pump. That's what Michelin is doing out in France. We worked with them to work on this, to make this tire that now will have road adhesion like the world has never imagined, simply because we can print infinite complexity. And it's not always about that. That's printing the cavity of the tool, but anyone who knows injection molding, I'm guessing there are people here who are in that world, you know that it's a very temperature sensitive process. And to cool that big slab of steel that is your tool, you normally have to drill holes in it, and those holes have to be straight because drills are straight. Well, now what you do, when you 3D print your tool, you can 3D print your cooling channels as a lattice that goes over that complex shape. So now you can very deliberately put your cooling exactly where you want it. You have extremely accurate temperature control. You can make this helmet, but more importantly, you can make another product that is especially temperature sensitive. You know what? Chocolate. So we have something to look forward to in the future. Now, what does this all have to do with Industry 4.0? Well, what started out as 3D printing a prototype turned into 3D printing a final end-use product. What's happening now is another exciting trend in that we are taking the 3D printer out of the back room and putting it right there on the manufacturing floor. So the printer, which is in this case a robotic arm, it preps the part, it prints the part, it cures the part, it does secondary operations to the part, and it assembles it right there on the assembly line. And that doesn't matter if you're making 1 million products and they're all identical, or if those 1 million products are each individual, because the process doesn't care. It also doesn't care if you're only making 1,000 parts. Now, injection molding hates those conditions. You can't win. But with 3D printing and robots doing all the work, that all comes for free. Now you can add to that a 3D scanner into the process, so each part gets 3D scanned while it gets made, and it gets compared to its digital twin, its CAD file for any deviations. So the software then gets to make an accept or reject decision right there on the fly. Not only that, when it realizes there are errors, it can actually correct them in the very next part created right there, or all over the world where these are being made the next instant. So as far as Industry 4.0 goes, that speaks right to the heart of it. Those are cyber-physical systems with autonomous decision-making processes. Where are we going to see this show up? On our feet. So these are the Futurecraft shoes, but a lot of companies are doing them. Nike, Adidas, New Balance, Under Armour. They're all making 3D printed shoes now. Now these are cool, they're complex. They have 20,000 individual struts there. Can't do that in the normal world. They have mechanical characteristics that change everywhere in the sole to give you optimum performance, but they're not going to stop there. That's just touching into this new idea of 3D printing shoes for the consumer market. Where they're going to go is more like what pro athletes have been doing for a while, where you walk into your shoe store, it analyzes your walk, your step, your foot, and it 3D prints a shoe custom for you. And every time you come back, it'll print your shoe just for you. Now, the difference pro athletes get is they get to walk off with a really cool 3D printed bag. That's why you want to be a pro athlete. So these three words, time, cost, and caution, are the death blow to innovation. We all know this. The longer it takes you to make something, the more expensive it is, the more you're likely to be cautious, which is the last thing you want to do in an innovative environment. Well, the first thing they teach you at Stanford Design School, where I used to teach, is fail early, fail often. And that means that the cheaper it is, and the easier it is to fail and to have experiments, the more your innovation is going to flourish. We sometimes call that shots on goal. The more shots you take, the more goals you score. Now, one of the companies that has been most successful with this is Formula One. They used to have a real problem, and the problem was designer designs part, she sends it to the machine shop, they take days or weeks to make that complex part, they send it to the wind tunnels, they test it, and the data eventually gets back to the designer to redesign for the next time. very long process. Now, the pace of innovation is set by the pace of fabrication. So now what happens? Designer designs part in their first 8-hour shift. They go home, go to bed. The second 8-hour shift 3D prints the part and preps the part. The third 8-hour shift gets it in the wind tunnel. And by the time she comes to work the next morning, all of the data from the previous day's work is there on her desk ready to go. So you can imagine if you are a Formula One company and you're trying to compete with these guys running at this pace, you better just stop doing it and find another line of work, because you can't compete with that kind of accelerated pace. Now, that's Formula One. It's aggressive, it's high budget, but it's not too different really from every other company. It's the company with the best use of the new tools and the best design process and the fastest process is very often the winner. Now, we all know that making really cool, complex stuff, we've seen the pictures. 3D printing loves showing pictures of complex things, but sometimes that's not what it's about. Sometimes simplicity is your best friend. An example of that. I used to ride a Ducati motorcycle. So this is what my weekend looked like. And anyone who's ever owned a Ducati knows this is true. So the problem is it has lots and lots and lots of parts. And parts are a headache for everybody. The manufacturer doesn't like them because they're expensive, it's tooling, it's upfront cost, lead time, it's heavy. The consumer hates them because it's heavy, it's points of failure, it's a lot of stuff to maintain, there's process burden, everything else. So with 3D printing now you have the opportunity to instead take a lot of different mechanical functionality and combine it into one complex part. And even though this one part might be more expensive than any one part on the other one, at the end of the day what you're saving is much, much more efficient. And you have a much less expensive and a lot more practical part in general. So that's called part consolidation. And while you're 3D printing a part, you get the other opportunity to do what was mentioned earlier, called topology optimization or generative modeling. Now, in short, topology optimization is the chance to take 30 million years of Darwinian evolution and condense it down to overnight. And so we were asked to demonstrate this for the Cooper Hewitt Museum in New York. And so they asked us to do a skateboard this way. The first thing you notice is that we didn't design it. As Andre pointed out, we became the curators of the design process, but the software designed the skateboard. We simply loaded in the forces and the torques and the newtons and all the physics, and then we went home. And the computer churned all night long, and then when we came in the morning, the computer was roasting hot, and we had software that showed our final product. And what Jason Dunn had just mentioned in the previous panel discussion was especially pertinent. He said that sometimes the farther you get into high technology, the more your final product starts feeling like it didn't come from a person at all, but it came from nature. And that's certainly what we're seeing. And we're seeing this happen everywhere. In architecture, this is from Arup. You can see the traditional product and how it's been optimized for 3D printing. And we're seeing a level of geometric efficiency that was never achievable in any other way. The aerospace industry, of course, loves this. I checked, and the Airbus A350 that I flew here on, it has over 1,000 3D printed parts on it. Because you get strength to weight ratio, you get efficiency, you get everything that the airline industry loves. And it's not just up in the air, it's down on Earth, everywhere from motorcycles to bicycles. Here's the gas pedal of the Formula One car. And part consolidation is also helping the car industry in all ways, because you have companies looking at taking all the complex parts of a car, in this case, 30,000 parts in a traditional car, and turning it down to 50 parts. Well, not only that, you can imagine the day when instead of assuming that cars are expensive and complex, you can assume that they are cheap and simple. So perhaps this is what the car of the future is going to look like. This is the EDAG Genesis concept car. It will be lighter, simultaneously stronger. It will be a faster time to market, but also yet more nimble and more adaptable to changes. And as we've all seen, the rocket industry is exploding right now, so to speak. And part of that is due to the fact that a rocket engine is inherently complex and takes a long time and great cost to make. Well, now, because you can 3D print the parts, you can, right there, print a new engine every 24 hours. That's kind of a game changer. Or these guys, relativity space. They talk about consolidating 100,000 parts into 1,000 parts. Massive part consolidation. So what that does is it democratizes the means of creating, in this case, a rocket. And it means that instead of rockets being the sole domain of nation states, they can suddenly become private devices that companies can create. And it allows the startup rocket company, which is a strange concept no matter how you slice it. Well, that's complexity being your enemy. Complexity is also your friend. And I started a company based on this 9 years ago. And it was looking at this. A miserable condition called idiopathic scoliosis that happens in girls mainly, ages 8 to 12 years old. Now the process makes a lot of sense. You just tell an 8-year-old girl to wear this 22 hours a day. What could go wrong? Well, what goes wrong is she doesn't want to wear it. And anybody who knows an 8-year-old girl knows that that means that it won't happen if she doesn't want to wear that. And so then she often needs surgery. And the surgery is as miserable as you can imagine. So the problem was not in the medicine. The medical approach works fine. The problem was the psychology and the way you treated the patient. So the process that I worked on was to say, how about we treat the patient with some respect? Treat them as a human being, treat their real human needs. So we designed it to be ventilated so she'd be comfortable. We came up with a digital process where we 3D scan her body, correct her digitally, and 3D print a brace, and let her choose the pattern. So then it's not a medical product she has to wear, it's a fashion product she gets to wear. And because all of a sudden she wants to wear it, she finds it beautiful, she wears it more, and then she avoids surgery more. So all this technology, all the complexity that we're given, is all about helping a little girl have a not miserable condition and avoid surgery. And it's working. And that's due to the complexity of 3D printing. So the same approach we used for prosthetic legs with this company I started called Bespoke. And the premise here was that it's bad enough to lose your leg, but then to replace it with a bunch of nuts and bolts and pipes, that's bad as well. And then also there's a social alienation where people in society are uncomfortable around somebody with a prosthetic leg. So the idea was to say, let's treat that as a canvas, as an opportunity for art and design. And let's really play up the beauty of the person and make it a thing that expresses who they are and makes them back into the beautiful person they should be. Lets them express their personality through their physicality. This guy lost his leg on the motorcycle. He's back riding the same motorcycle, but with a leg that looks like it's part of it. We let them do their sports again and be comfortable being on the team and not feeling like an odd person out. This guy, he just said he just misses his tattoos. And could we give him his tattoos back? So we 3D printed those right on in. This woman said that she missed wearing stockings. She really liked wearing fishnet stockings. Could we design accordingly? And now she's a model in Los Angeles and she buys her clothes to match her leg. John asked if we could make him a sports car that he could wear. And when I put this on him, his wife was standing next to me. And she looked at it. She thought about it for a moment. She said, I really like your new leg better than your old leg. And he looked at me and he said, nobody says that to an amputee. That's a strange thing to hear. But that's the power of complexity and geometric flexibility with design. Is that you have the opportunity not just to create a product, not just to make it more efficient, but to change the social relationship between society and the person who has that product as a very intimate, necessary part of their daily life. I wasn't actually going after all of that. My biggest picture was to address this challenge, which is the fact that people in the world who really need prosthetic legs most likely will never see the kind of doctor needed to address their problem. And that will not change. In fact, it'll only get worse over time. The only solution for that will be to go digital. Digital and disruptive and exponential. So the premise was, can you take a 3D scanner, and everybody in this room has a 3D scanner in their pocket, 3D scan the person, their sound side leg, their lost leg, send it up to the cloud automatically generates for them a prosthetic limb, ready to go, medical quality, sends it to the next available 3D printer, which then prints it when it has discretionary bandwidth, and assembles the part and sends it to them. Now you get a few extra benefits. It's unique to them, so it creates their shape again. So it removes some of that social alienation. It's made locally. It's also dishwasher safe. Now, we made many of these, and the reason that a small venture-backed startup could make so many of these prototypes and get so many people up and walking was that it only cost us about $5,000 to make each unit, each prototype. At that low cost, and at about a week's turnaround time, we have a lot of shots on goal. We have a lot of room for experimentation and exploration. So we've come a long, long way since that first 3D printed car dashboard. We've gone from making prototypes of parts that would one day be manufactured, to making end-use parts, to data visualization, to tooling that makes the parts, to everywhere in the manufacturing process. Well, there are still many, many opportunities in 3D printing, and the technology is growing faster than any of us can ever get our heads around. The challenge lies in all of the companies and all of the innovators in connecting the dots, in connecting the need and understanding and identifying that need, and connecting with this technology that can solve it in a way that nobody else has ever thought of. And sometimes that solution doesn't come from the CEO people or the design directors. Sometimes it comes from that person on the factory floor that nobody listens to nearly enough. Or sometimes it comes from a couple kids right out of college with a crazy idea that nobody else would listen to or expect to be disruptive. Those are the ones that companies should be paying the most attention to. So when the tools are the same in the old world of manufacture, well, the advantage goes to the big companies. They've got the budgets, they've got the brand, they've got the network, so they're safe. But when a new tool comes online, everything shifts. And now the advantage goes to the little player. Whoever's the most nimble, the most aggressive, the most flexible, whoever can best address a challenge with the capabilities of that new tool. Well, now all those tools have been democratized. We all have access to the same 3D printers and the same 3D scanners and data and robots. The challenge is no longer in the limitations of the tools. The challenge is now only in the limitations of our own imaginations. Thank you for your time.
Thank you very much, Mr. Scott Smith. The next topic will be manufacturing in space and how it changes manufacturing on Earth.